part 2 of the Unit 3 geometry review. This is just all going to be question 8 since there's so many parts to it and it's more complex. First of all, figuring out if the triangles are similar and why they're similar. So we need to state the triangle similarity thing or theorem. So we can use angle, angle, side, angle, side, and side, side, side. Justify why we can use that. So listing out the parts, each part of those, whatever one is true, and the similarity statement. So triangle ABC is congruent to triangle, or similar, sorry, to XYZ. So for this first one, I'm going to see if the triangles are similar to each other. So relating each side, 30 over 24. These should all be equal fractions. 25, and then 35 over 28. If I even just type these into a calculator or reduce the fractions, I can clearly see that they're close, but they are not all equal. So because 32 over 25 is not proportional, we cannot use side, side, side. We don't know anything about the angles. So since the sides aren't proportional, or dilated with the same scale factor, triangles are not similar. Okay, part B. It tells us that the angle A and angle C are 85 degrees. We also can see that angle B, or angle DBC, is 42 degrees because of vertical angles. So, sorry, one's 53 degrees, one's 85. So we need to use 180 or 180 triangle sum rule to find this angle E, or you can find angle D, but that should give you the 85 degrees. So we know that so this is how we would list out the proof. Angle E is congruent to angle C, since triangles add to 180. So this is part of the justification. And then angle ABC, or ABE, is congruent to angle DBC because of vertical angles. So by angle similarity theorem, triangle ABE is similar to triangle DBC. So the justification is right here, the similarity theorem and the triangle statement, similarity statement. Okay, part C, if we have these side lengths, that means that this whole side length is going to be 24 from P to Q. P to R is going to be 20. So we need to see if these are all proportional. So if we have 12 over 16, these two sides, and then if we relate that to being 18 over 24, and let's see, 15 over 20. So relating each of the sides of the smaller triangles to each of the sides of the larger triangle. If you type these into a calculator or reduce the fractions, you can see that they all reduce to 3/4. So they're all equal to 3/4. So justification, since all sides dilate by 3/4 or 4/3 from triangle PQR to triangle backwards PXY to triangle PQR, then by side, 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 since we know everything about the sides. This could also be side, angle, side, since we know that angle P is congruent to angle P. Triangle PXY is similar to triangle PQR. Okay, part D, I'm going to find the third angle. I know that both of these triangles have a right angle, a 90-degree angle, but they have one of them has 61s and one has 34. So making sure that their third angle is congruent. Angle Y is going to be 180 minus the 90 degrees minus the 61, which equals 29 degrees. So because 29 and 34 are not congruent, that means that they only have one congruent angle. So since only 90 degrees is congruent, triangles are not similar. Okay. And then if I do this one, I at least know that angle D is congruent to itself, just like how it was in part C. But then I want to relate each of these. So if I go 24 over 44, because that's going to be the whole side length, is that equal to 35 over 65? And it is not, because 24 over 44 is 6/11ths, and that's not equal to 7/13ths. So I do know about that angle, but the sides are not proportional, so they are not similar. Okay, and the last one, I'm going to use my scale factors again, looking at what the information is. If this does work, it's going to be side, side, side. So if I relate each of these, I get 30, or you can do it the opposite way. 30 over 42, that's going to be, this is an isosceles triangle, so another 32 over 42. We know that those are at least going to match. And is that equal to 25 over 35? And those all reduce to 5/7. They're all equal. So that's my scale factor. So all sides are proportional by 5/7. So by side, 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 we know that triangle ADE is similar to triangle STW. And there you go. There's how we can use angle, angle, side, or side, side to show triangle similarity.